All right, 86. Hopefully that jumps out at you as an integration by parts. I'm sorry, partial fractions problem. So I'm going to rewrite this as some constant a over x minus 1 plus some constant b over x plus 3 and figure out the integral of that. I know that a times x plus 3 plus b times x minus 1 must add up to the numerator of the original expression, which is 1. If x equals negative 3, I get 0 in this term, and I get negative 4b equals 1. So b is negative 1/4. If x equals 1, then I get 4a plus 0 equals 1. So a is positive 1/4. So that means the original problem here is the same thing as 1/4 over x minus 1 minus 1/4 over x plus 3. These now become pretty simple integrals. I get 1/4 natural log x minus 1 minus 1/4 natural log x plus 3 plus c. Because I'm subtracting two logs, I could factor out this 1/4 and then take the log of the quotient x minus 1 over x plus 3, and that looks like it's letter A. All right, number 7 is one of these known cross sections. I'm going to do a little sketch. Y equals 2 minus x squared is our graph. Really no need for a calculator here. It says it's the section in the first quadrant, so it's this area. And you're going to make a 3D shape where every cross section perpendicular to the y-axis is a square. So I'm going to take this length and build a square out of it. Right? So we'll try to do a little drawing, but it'll look something like that. And then this one would have a square that's a little bit smaller, and at the top you'd have a small square. Ultimately, I just need to figure out the area of one of these squares. My equation is 2 minus x squared, but this is going to be a dy integral, so I need to solve for x. So x squared is going to be 2 minus y. X squared is going to be plus or minus the square root of 2 minus y. And in the first quadrant, x is going to be plus or minus. In the first quadrant, I can just focus on the positive part. So this 2 minus y is this length right there. And so if I build a square out of that, it would be 2 minus y squared. If I integrate all the squares from 0 all the way up to the top, which is 2, I will get the volume of this region. Simplifying, you get the integral from 0 to 2, 2 minus y dy. There's no pi in my answer because it's all squares. You can actually rule out a lot of these just by thinking about the dx dy question. So B is our answer for 87.